Alright, this is my Lab 5 presentation on electric circuits and current. The main goal of this lab was to make predictions on and investigate how circuits worked in different scenarios. In order to achieve this, we mostly just put together a couple of other different circuits to see what kinds of outcomes we could have, different scenarios we can make. To do this, we started by, in the pre-lab, creating a very simple circuit with just a battery, a couple of alligator clips, and a light bulb to make the light bulb light up. And we tested several different types of materials, such as metal and wood and plastic and whatnot, to see what kind of materials could best be used as conductors. And then when we got to the lab, we had a little bit more of a structured setup where we would predict how current acts in different circuits, and then we used a digital multimeter to measure currents in different circuits and compared the two to see if they matched up or not. And then afterwards we then moved on to making several different circuits using switches, different kinds of switches, to make several different scenarios. In this specific image, we see a battery hooked up to a light bulb. It's hard to see, but the light bulb is lit up here. The way this works is just the bottom of the light bulb is touching a plate that is connected to one side of the battery. The sides of the light bulb are connected to another plate that's connected to the other side of the battery. And that allows current to flow through the bulb and light it up. Here we're just measuring the current that's flowing through the light bulb in that scenario. This is the first scenario that we put together. The scenario is of a tunnel. The theory is a person's walking through the tunnel and they switch on the first light and they walk further down and they switch on another light, and when they do that it cuts the first light off. This circuit allows you to do that. So the first switch down there on the bottom left cuts on the first light, and you get further on to the top right switch and you flip it on. So you're going to cut off the first bulb and cut off the first bulb and cut on the second bulb. This is the second scenario of Christmas lights. The whole deal here was to make a scenario where all the bulbs would stay lit 100% of the time. So if one bulb went out, the others would still work just fine. This is the third and last scenario. It's the entry and exit light switches, where it's like a room with two entrances and light switches at both entrances. You go in the room, then one entrance, you flip on the light switch, and you exit out of another entrance or an exit at that point, and you switch it off, and both switches can either cut on and cut off the light bulb. And that we accomplished this goal ultimately. We investigated circuits, how they worked, made measurements using a multimeter to confirm our predictions. We then used that knowledge to construct other circuits using different switches to make different kinds of scenarios. So yeah, that's just about it.